Good afternoon, good evening, whatever time you're watching this video at. We have a question here. Integrate 3x squared plus 4x minus 5 over x cubed plus 2x squared minus x minus 2 with respect to x. All right, now, if you try to factorize the numerator, you may not find the factors. So the best thing to do is that factorize the denominator. I've tried it, it's not working. Let's do the denominator first. Now, when we look at the denominator, we can actually factorize it by grouping the terms. So you have x cubed plus 2x squared minus x minus 2. We can group the terms. Here, I can group the terms. I can get x squared, x plus 2. And here I can group the terms, minus 1 out, then x plus 2. Check that x plus 2 is common, so I'm going to have x squared minus 1, then x plus 2. I can still factorize this one, the difference of two squares, which I know you know by now, x minus 1 and x plus 1, then x plus 2. So the denominator is quite factorized. So now let's proceed. So we have now this over x minus 1, x plus 1, and x plus 2 dx. Recall partial fractions. We can write this into partial fractions. A over x minus 1 plus b over x plus 1 plus c over x plus 2. We can now do the partial fraction. Of course, by partial fractions, it's very simple. What you do is that just get this part and say 3x squared plus 4x minus 5. Then here's what you do. You know what is under a, just get a, then multiply with whatever that remains. All right. You move on. You know what is under b, then get anything that remains. Then you know anything under c, then get whatever that remains. That is very easy. Now, these are just normal factors which you can actually equate to 0. So set x equal to 1. If I set this one equal to 0, it will be equal to x equal to 1. So now, all right. So if you set this part here, the factor equal to 0, you get x equal to 1. Now substitute x equal to 1. If you put x here, that becomes 3 plus 4 minus 5 equal to. If you try it, just check where there is x minus 1. Here, everything under x minus 1 here will give you 0, will give you 0 there, so you remain with a. So if I put 1 here, that becomes 2. If I put 1 here, that becomes 3. So 3 times 2 is 6a. So this eventually will give me, what do I get here? This is actually negative 1. So, check here. Check here. So you have plus, so this would be 7. 7 minus 5 is 2. So you have 2 equal to 6a. So this will give us a equal to, of course, this can be reduced, 3 over 2. Right? No, there's 1 here. So this would be 1, 1, 1, 1. So 1 over 3. This is our a. Let's find, we set x equal to negative 1. If you set this one equal to 0, of course, x will be equal to negative 1. So if you put negative 1 here, it just becomes 3. All right, put negative 1, that becomes negative 4 minus 5 equal to, where there is plus 1, you get 0. There is plus 1 here, so you get 0. There is plus 1 here, you get 0. You remove that one here. Negative 1 minus 1, you get negative 2. Negative 1 plus 2, you get 1. So eventually you get negative 2b. And here what we get, this is negative 9. Negative 9 plus 3, you get negative what? 6. So as negative 6, yes. This is 3 minus 9 equal to negative 2b. For those who are doubting, meaning b is equal to, what is this? This is negative 6. That will be negative 6 over negative b. So negative 2. So b will be equal to 3. So b is 3. All right, so b is known as 3. Let's now find the other one, which is c. So we set x equal to negative 2. Because x plus 2, if you equate to 0, you get x plus 2. So x is equal to negative 2. So let's put negative 2 here. That will be 4 times that will get 12. If you put negative 2 here, that will be negative 18. Then negative 8 minus 5 equal to, where there's plus 2, I'll be getting 0. So 0 there, 0 there. So I'll remain here. If I put negative 2 here, this becomes negative 3. If I put negative 2 here, this becomes negative 1. So negative 1 times negative 3, what do I get? 3. So 3c. And of course, here you can add if you want that to be 2. 12 minus, this is just 23. No, 13 equal to 3c. And what do we get here? Negative 1 equal to 3c. And therefore, c is equal to negative 1 over 3. Now, we've already found everything that we need. We take it back into the equation, meaning our integral now becomes z. So we are now be integrating this guy here. So where there's a, we put 1 over 3, meaning 1 over 3, then x plus minus 1. The next one is b, which is 3, so that would be a 3 over x plus 1. Then this one is minus 1 over 3, then x plus 2. Then you say dx. So we are integrating this now. It's now, this one is now easier to deal with. All right. So you can actually try to say, okay, just like you can break this into parts. Integrate this part, you get 1 over 3 natural log of x minus 1 plus integrate this one, you get 3 natural log of x plus 1 minus 1 over 3 natural log of x plus 2, then plus c. So that becomes our answer, ladies and gentlemen. This is how power of partial fraction decomposition can help you integrate such complicated integrals. Nevertheless, don't forget to subscribe and follow for more.